Hello, we are Team 9. Last week we presented the construction method needed for the leaning tower of CCTV headquarters. The importance of the core in leaning buildings increased, and climbing systems were used to strengthen this core. In addition, by using the monolithic structure construction method when pouring concrete, CCTV tower has strong strength and stability. This week, we will introduce the problems that arose while constructing the cantilever portion of CCTV's headquarters and announce how they solved. CCTV headquarters takes the form of two leaning towers meeting at the top in the form of a cantilever of enormous depth. The cantilever extending from two separate inclined towers and meeting in the center have to be constructed while maintaining stability and balance compared to other forms, so the process was not easy and required various structural analysis. Therefore, to construct the cantilever of the construction company considers three methods. The first method which is considered was the temporary tower support method. This method uses temporary towers to support the structure while the cantilever of the building is constructed. This temporary tower provides the necessary support until the cantilever has achieved structural stability on its own. After that, the temporary tower is removed. The Millau viaduct is one of the tallest bridges in France, constructed using multiple cantilever sections. Building a bridge with a very high altitude and long span required precise coordination and support of each section. Therefore, the complex process could be performed more safely by using temporary tower support during the construction of this bridge. As in the previous example, thin and long structures cannot resist bending moments on their own, so this method is used not only in bridges, but also in buildings with long and thin structures such as bridges. However, in the case of CCTV cantilever, it is very thick and heavy, so there is a problem that it requires a strong and large temporary tower that can withstand a large load. Designing a temporary tower that could withstand a large load was not easy in itself, and even if designed, a lot of labor and cost were required to install, maintain, and remove the temporary tower, so a method other than this method was needed. The second method considered is the lift-up prefabrication method. In this method, the cantilever portion of the building is manufactured in a factory as large-scale modules, which are then transported to site and installed using a crane. Only assembly work is mainly performed in-site. This method has the advantage of significantly reducing on-site work time and ensuring quality because the modules are manufactured in a highly controlled manufacturing environment from external conditions such as weather. The Almeida Sky Building's floating garden is a representative example of construction using a method of manufacturing modules and then lifting them. This building is located in Osaka, Japan, and is especially famous for the floating garden located at the top, a characteristic structure that connects two towers. The Almeida Sky Building floating garden consists of an observation deck and a relaxation area for visitors. It was stubborn to use prefabricated modules because the internal structure was relatively simple and did not require additional heavy or complex equipment. However, In the case of the CCTV headquarters building, the cantilever part is structurally complex because it accommodates the broadcasting studios and officers. This results in increases costs and technical difficulties in module production. Additionally, the complex structure also increases the weight of the module. This causes additional problems such as the transportation cost of moving modules from the factory to the field has increased, and the process of lifting and assembling heavier modules has become much more difficult. So which method did OOP adapt to solve the problems of the first and second method? The method ultimately adapted for cantilever construction of the CCTV headquarters building is the balanced cantilever method. First, let's check the process of this method through a 3D modeling that we created ourselves. As you can see, during cantilever construction, a horizontal member is supported through a diagonal member, and construction of two independent cantilevers is carried out. In this process, a lowest part of the cantilever meets first, and then construction of the remaining part processes. This method is easy to adjust on site and can more accurately meet the design requirement of complex structures through a gradual construction process. Additionally, because it supports its own load, much less temporary structures are used compared to method 1, and because both cantilevers are constructed on site at the same time, it takes less time and costs less in terms of transportation and crane operations than lifting complex and heavy modules using method 2. In other words, we were able to solve the problems of the first and second method by conducting construction using the balanced cantilever method through accurate calculations. However, challenges remain to be addressed with this approach. If constructed this way, the two cantilever must engage exactly in the center. However, the metal members used during construction have distinct thermal expansion and contraction effects which generate stress. This is the main factor stopping the two cantilevers from meeting exactly in the center. Let's take a look at how this problem was solved. First, in order to effectively manage the thermal expansions, contractions, stresses, and to achieve optimal structural alignment, expansion joints were used to connect the tower and cantilever. Expansion joints provide the necessary flexibility at the connection points of structures during construction, allowing them to withstand expansion and contraction due to temperature changes. This plays an important role in minimizing the negative impact of heat-induced deformation on structure stability. Additionally, when the cantilever structures extending from both sides meet in the center, they are connected through 7 links. This connection was made by a pin joint. Pin joints allow rotation of members but limit horizontal or vertical movement. By connection the 7 links with pin joints, each tower is designed to respond independently to loads by supporting it horizontally and vertically but also allowing rotation. When constructing high-rise buildings or complex structures, wind can be a big variable. Wind places additional dynamic loads on structures and can affect the safety of construction equipment such as cranes. Therefore, construction of the CCTV headquarters building was carried out in a morning and a windless day to minimize movement of the structure and ensure maximum construction precision. Morning hours are generally chosen because there is less wind and the atmosphere tends to be more stable. Additionally, since the building's connecting elements and structure joints are directly related to the building stability, their precise adjustment is essential. At CCTV headquarters building, a length of all connecting elements were finally measured 24 hours before ground level. By measuring at the same time the day before, the environment and the day of construction was predicted as closely as possible to maintain connection elements, that optimal condition and minimize the impact of environmental changes or other factors on the day of construction on the structure. After construction of the cantilever portion of the CCTV headquarters building was completed, a continuous steel plate deck was installed. Steel decking prevents the load from concentrating at a single point in the structure, and this part of the maintenance design process to effectively distribute the loads throughout the entire building. In addition, by installing a steel plate deck before pouring concrete, the basic framework of the structure was established and prepared to safely support the weight of the concrete slab to be added later. Today we learned about the three cantilever construction method of the CCTV headquarters building that the construction company considered and why the balanced cantilever method was adapted. In addition, we learned how to achieve accurate engagement of the cantilever, which was most important when applying the balanced cantilever method. This week, we learned about the cantilever steel structure construction process, and in the remaining weeks, we will learn about the rest of the cantilever construction process and CCTV headquarters HVAC system. Thank you for listening to the presentation. We were Team 9.